All right, welcome, ladies and gentlemen, to another part of the 4.4 section, graphing cosine function this time. You'll notice that this is going to follow a lot like the sine graph or the sine video that was posted earlier. We're going to continue using the 5-point method for cosine, and we're also going to show the transformation method as well. So the parent function f of x equals cosine of x, you'll notice a lot of the things are exactly the same. The domain of cosine is all real numbers. The range, again, is -1 to 1, and you can notice that, again, from your unit circle, the biggest coordinates you get are 1 and -1. The period for the cosine function is also 2 pi. The first difference, however, is the fact that the cosine function is an even function. And here is what the graph is going to look like for the cosine function. It's going to look very similar to the sine, but using the points from our unit circle, the cosine of 0 is 1. The cosine of pi halves is 0. The cosine of pi is -1. The cosine of 3 pi halves is 0. And the cosine of 2 pi is 1. And going backwards in the other direction using the negatives, this becomes -pi halves is 0, -pi is -1, -3 pi halves is 0, and -2 pi is 1. And we get to connect the points thusly. These are maximum points, so we can't go above those coordinates there. And then we go down here. Then we come up here. Again, I didn't really mention this in the last video, but please note that there are no sharp corners on any of these graphs. So if you're drawing sharp corners, you're not trying hard enough. These are all rounded corners. These coordinates that we are finding here at the top and at the bottom, those are maximums and minimums. And therefore, they have to be rounded. All right, so there's the graph of cosine. If you wanted to see the graph of sine, I will put that in here for us. The graph of sine just does this, and you'll notice they look almost identical, but it ends up being that one of them, they are phase shifts of one another by pi halves units. So this blue line here is sine, and the red line is cosine. All right, so let's look at this, the sinusoid. It's still called a sinusoid, even though it's cosine, and everything here is exactly what you should have on your notes already from sine. So there's not really anything else I need to explain here. I'm just going to kind of skip through this, just kind of to make you sure you understand. A, B, C, and D still follow the same exact rules as the sine function. So the 5-point method also looks identical. So the 5-point method is still letting the bx minus c equal these 5 values. And the difference now comes that if we find those values again, as we did in the sine video, we got pi fourths, pi halves, 3 pi fourths, pi, and 5 pi fourths, just using the same process we did in the last video. But now if we plug in pi fourths, times 2 is pi halves, minus pi halves is 0, and cosine of 0 is 1. And by plugging in these other 4 points, we get 1, 0, -1, 0, and 1. So we can go to do our graph. And we go 1 pi fourth, 2, 3, 4, and 5. So we get pi fourths and 5 pi fourths, +1 and -1. And we can go like this. Pi fourths is at 1, 2 pi fourths is at 0, 3 pi fourths at -1, and pi is at 0, and 5 pi fourths is at 1. And then we can continue our curve. All right, so notice again the amplitude is up 1 and down 1 because their 1 is in front of cosine. You notice the distance between pi fourths and 5 pi fourths is, which is pi because it's 2 pi over 2. And what we're going to use here is that cosine starts up and ends up. So we're going to use that kind of symmetry to graph this function rather than using the 5-point method. So going exactly like we did with the sine function, I'm going to look at my amplitude, which is 2. My phase shift, which is c over b, so it's pi units right because of the minus. And it's up, oops, sorry, that's not how we're doing this. We're doing center, a center line, which is y equals 1. And notice my period is 2 pi over 1, so it's 2 pi in this case. Okay, so we went pi units to the right. So there's pi. And we're going to go, there's 2 pi. And here's 3 pi. So our period's 2 pi, so we're going from pi to 3 pi, which is our period. And we need to go up 1, so we need to go up to a new center line of 1. And we need to go up 2 from that, which is 3, and down 2, which is -1. Now we can use things we know about cosine and ones we don't know about sine. Okay, so for cosine, it normally starts at the up. Normally starts at 0, 1. But now we've gone pi halves to the right with a new amplitude of 3. So starting at pi halves to the right, I'm going to start at my amplitude up. And then my finishing is also at the up because I always have to finish exactly where I started in one period. And then if you look at the pattern from the parent function, the first quarter and the third quarter are on your center line, and the middle is down at the bottom of your amplitude. And then we can connect, once we have 5 points, we can connect those 5 points thusly, and we get a cosine curve, which again will look a lot like the sine curve. All right, you'll notice that these functions look a lot like the ones in the sine video because they're exactly the same. I just changed sine to cosine. So again, my amplitude is 0.5. My period is 2 pi over half, which is 4 pi. There's no phase shift and no vertical shift, so I don't have to deal with either of those. But I need to go out to 4 pi here. I need to cut that in half to get 2 pi. Then I need to cut those halves in halves again and get 3 pi and 1 pi. And I need to know that my amplitude is 0.5 and the other direction of -0.5. And now I have everything I need in order to graph. At 0, cosine starts up. It goes to the center line, down, center line, up. And when I create the graph with just my quarters on here, those dots go nicely together on those quarters. And there we have our function. Again, my period is 4 pi. My amplitude goes up a half and down a half with no phase shift and no vertical shift. And we're going to finish on the same function again, just now with cosine. So my amplitude is 5, and again, I'm going to note that it's flipped over so I remember. My period, this case, is 2 pi over pi, which was 2. And my center, my new center line is y equals negative 5. So I'm going to pay attention to myself this time. I'm going to draw my y-axis or my x-axis way up here. And I'm here, I'm at negative 5. My amplitude is is 5, so I need to go down to negative 10 and up to 0. So I'm going to put in my new center line here. There's no phase shift, so my period is 2, so I get to start at 0 and you get to end at 2. My halfway is 1. My other halves are my half and my 3 halves. And now here we got to pay attention to the flipped over. Cosine normally starts up, but because it's negative, we're going to start down below. And 1 full period away, I'm also going to be below. At halfway, it's going to be at my highest amplitude, and at my other halves are on my center line. At my quarters, I mean. And there we have the cosine function of the same transformations as the sine function. And that is actually going to finish us off for cosine as well. We will work on this quite a bit. Graphing itself will take us a few weeks. So kind of get in there, dig deep, and really start to graph these functions. All right, I will see you guys tomorrow.